be really fun. We're going to focus a little bit more on bridging CosmWasm to other ecosystems. And we have a great roster for the speakers. We have Luis Quispe, Head of Security from Helborn. We have Ethan Frey, co-founder of Confio. We have Karel Kubat, CTO from Composable Finance. And Susumu Toriumi from DataChain. Welcome, guys. So I'm going to get started, get the head rolling, and I wanted to ask Ethan, first of all, what do you think are the biggest challenges of bridging CosmWasm to other ecosystems?
Hello. Well, first of all, thank you for having me here, and thank you, Quispe, for organizing this amazing event. Yeah, big thanks for Quispe, first of all.
Yeah, thank you.
So yeah, I think the biggest challenge right now is actually more developers. So it's been amazing adoption. Last year, we've gone from like 3 or 4 mainnets to over 20 mainnets. I can't count them anymore. I have no idea. I keep hearing people saying, oh, this chain is doing CosmWasm. I have no idea anymore. So I think the adoption on Cosmos has picked up heavily, and it's really the number of devs. So we're actually launching today, if you didn't hear, the CosmWasm Academy. We just launched that to train devs, and that will be teaching new CosmWasm contracts to run all these chains. To run on things like Juno and Osmosis, but also on Secret Network, which is different, on Composable Finance, on every other chain coming out there that wants to run CosmWasm. So I think it's one way you can do that. And we'll be adding more stuff about IBC classes, how to do IBC contracts. So I really think education is a key. So check out the Academy and other education coming out from us.
Amazing. I definitely agree with that. Education is key. Karel, I wanted to ask you about Composable. I'm also a really good knowful about the Polkadot ecosystem, and I know you guys are working there, but wanted to know what is how is Composable bridging CosmWasm to Substrate, and what's the potential benefits for both ecosystems?
Yeah, so we're first and foremost a Polkadot parachain, which means that our chain works on a totally different SDK, Substrate. We run our chain code inside WebAssembly itself, which means that we had to do a lot of re-architecting of the CosmWasm VM, basically rebuilding it from scratch to work within Substrate. So I guess we've done the second full implementation, which is kind of fun because we did find some bugs in the official implementation as well. So it led to being very valuable overall. CosmWasm itself works really well in Polkadot too, because the model is very similar, right? Many chains communicating with each other. So you want an actor model for your smart contract, and it's a Rust-based ecosystem. So there's a large developer overlap too. And the second component is bringing IBC to the Polkadot ecosystem, which is a slightly larger challenge, to be honest. We've been working on that as well for over a year now, and hopefully launching that within about 3 months. That is a lot of work with the IBC core team, writing light clients, etc. But hopefully in about a year time we'll get to the space where Polkadot parachains are to Cosmos chains exactly the same. Just opaque sovereign chains that you can communicate with over IBC that may host CosmWasm smart contracts and are, to be honest, part of the same supercluster.
Amazing. Excited to see that. Susumu, how is DataChain applying IBC to the EVM-based chains?
Yeah, thank you. So just a small introduction of the DataChain. So DataChain is a firm believer of IBC, and we are main contributor to IBC Solidity, which is a Solidity implementation of IBC. And we are currently working on bringing IBC to EVM-based chain through our product called LCP, which is a light client proxy. So IBC is arguably the most secure and trust-minimized way of interoperability, but the on-chain verification incurs a lot of gas, and they consume a large portion of block size. So we mitigate these problems in a practical way. So we introduced the security-enhanced hardware, trusted execution environment called LCP node, to substitute the part of the on-chain verification to achieve the ultra-gas efficient verification, yet without sacrificing the trust minimization thanks to the remote attestation technology. So we will use this technology to build an IBC bridge between Ethereum POS to other EVM-based chains. And soon after that, we will expand to other ecosystem, CosmWasm and Polkadot. And at the lunchtime, I introduced LCP to Ethan, and that we can enable interchain contract call within these other ecosystems. And he's kind enough to say that this is significant. So hand it over to Ethan, why this is so significant.
Yeah, I think the interesting point here was just talking about bringing actually IBC to Ethereum, EVM. And the way that CosmWasm brings it to Cosmos SDK, the contracts are actually speaking the protocol themselves. So a contract can define its own new protocol, not just speak existing ones, but develop new protocols that handles the contract callbacks, the handshakes, the packet processing. The same way they will expose the IBC Solidity, the Solidity contract can say, okay, on connection init, on connection accept, on packet receive, on packet acknowledge, it will actually build any protocol it wants. So you can develop a new protocol that never existed before. On a CosmWasm contract on one side and an Ethereum contract on the other side, and actually develop new cross-chain technology. I think that's actually very, very significant. It's not just building upon bridges, but actually new protocols. The same way that I thought is very, very significant that you can speak CosmWasm to CosmWasm. So I'll speak more on that later, but
amazing.
I think it's basically the same idea that you'll be able to in the future when that's fully realized. I think an open whole ecosystem.
Yeah, thank you.
Great.
If you guys are using hardware at the station, don't you introduce a trust component on Intel, for example? And that being a US company, not perhaps being the wisest thing for trustless infra?
Yeah, that's the little additional trust assumption. We need to rely on the Intel or data center to attest that the hardware works fine and the running binary is sound. So that is the additional part. Yeah, thank you.
Luis, what would you say are the main security risks with bridging?
Oh, bridges. I really love this technology. I really love. But let's recap some of the recent hacks that happened to the bridging technology. So, January 2000, this year, 2022, what happened? Qubit was hacked. Qubit bridge was hacked. It was $80 million worth loss. But maybe 80 million is not big enough. Let's set the bar higher. February, the next month, Warhol was hacked. Warhol bridge was hacked. The amount, $300 million. But guys, that's not enough. March, the next month, Ronin was hacked. More than 600 million was lost. I think, if I not wrong, it's the largest hack in the DeFi world. If we do a summary of all the hacks that happened just in bridge technology in the last 2 years, it's around $2 billion, just in bridge. So, does it mean that bridge is bad? Not, anyway. But we need to consider what are the main vulnerabilities that could impact the bridge technology. So, for example, let's talk about the false deposit events. I am sure that many of you already know how bridge work behind the scenes, but for those folks who don't, just let's recap a little. We have contracts in one chain and contracts in another chain. So we lock tokens in one chain, and we mine rapid tokens in another chain. So in order for this to happen, we have something, a technology that monitors the events that one contract in the first chain emits. So if a contract emits an event, and this bot is monitoring that, this relayer is monitoring that, what happens? If I'm able to create a false event, it means that the other chain is going to accept as a true transfer, for example. So that's what happened, for example, in Qubit. The attacker was able to create a false event, and they were able to steal $80 million. Okay, that's regarding events. Now let's talk about fake deposit. Is it possible? Of course. For example, in Warhol, attackers were able to forge a signature, a validation signature of one of the nodes. What happened? They create a false deposit. So they don't deposit, but they made the contract believe that they deposit. At the end, what happened? $3 million loss. And also we have something that is very particular to the decentralized world. It means if we create or we work with a decentralized consensus algorithm, we need to believe that the data providers are decentralized or not. Let's see what happened to Ronin. Ronin had 9 validators. 4 of them were in hand of one company, SkyMapes. So an attacker compromised SkyMapes. What happened? All the keys were compromised. At the end, you have 4 out of 9. They only had to have one more validator that was hacked in an ERPC node, and they had 5 out of 9. That's all, game over. So they were able to hack and make a valid transaction. So what is the conclusion of all of this? There are some vulnerabilities that are common to this kind of technology. So as far and as long as developers are aware of this kind of vulnerabilities, they can prevent them to happen. And believe me, guys, if this happens, if there is one line of code that is wrong, it's many millions that are in game. So let's be aware.
So talking about that, it seems like many errors are because of communication. So I wanted to go with you, Ethan, talking about the status of the contract-to-contract IBC calls. How do you expect this functionality to evolve when other ecosystems beyond Cosmos start adopting CosmWasm?
Thank you. Before I go into that, I want to talk about contract-to-contract calls in Cosmos DK first. So if you don't know, basically IBC isn't just moving tokens. It's not just interchain accounts. It's basically an arbitrary bridge to move packets back and forth. You can think of it as a very provable asynchronous messaging protocol. On top of that, we build other protocols. So a lot of these hacks that you mentioned are actually base layer hacks. They were forging the relayers, tricking that something happened that never happened. What IBC does is a whole lot of technology written in Go by the IBC Go team, over 3 years now, refined, tested. It's basically the whole bottom layer, guaranteeing this chain actually did this chain actually said this. That has been now tested and refined, and we can take it for granted. We can build on top of it. So that's like 80–90% of the security attack vectors, which is basically guaranteed you inherit it. You don't build your own bridge. It's too hard. It's too much to do. Like, you can go wrong so many places. So let's use IBC. Everyone should use IBC. And I think the two of you are bringing this new ecosystem because of that, because once you have that, you can start building protocols very quick, because you don't have to worry about the huge bridge, you just worry about application level security, which is much, much easier to worry about. It's still a problem though. So at this point, you basically I have protocol here and protocol here talking to each other. And I don't have to worry that this one might not have actually said that, or this might not have said this, or it might not show up. Guarantees, I have guarantees. But on top of that, I have to make sure that I don't have an error in protocol. But it's just like any contract. If I call an AMM and it lets me suddenly withdraw 3 times as I should draw when I'm withdrawing my LP shares, or if I'm able to do a swap and get more money out than I should get out because they don't calculate the spot price properly, or they do a spot price instead of the actual curve price for the slippage, then I can abuse it. It's the same idea. So these interchain protocols in CosmWasm are basically like, they need a little more reasoning, I think, but basically the same attack vector is doing a contract-to-contract call in the same chain. That's at least in Cosmos, because you can reason about a lot of that same stuff. You have the IBC guarantees, and you say, okay, IBC works, I trust that. A lot of smart people are working on that. I can just worry with the application. So if I have my AMM calling my liquidity, my lending protocol, there's lots of places for error there. You want to audit it. And if I have my AMM calling liquidity protocol, another chain, I need to verify that too. But it's not that much more space for error.
Amazing. And Susumu, I wanted to ask you about IBC use in traditional enterprise.
Okay. So I'm not sure that this is an exciting topic to Cosmonauts, but we are discussing with traditional financial institutions about how they can leverage IBC, trustless interoperability, to their platforms, private enterprise blockchains, managing the private assets like securities, bonds, and real estates. So hopefully, if we can build trustless IBC bridge between them, we can bring the real-world asset to Cosmos, and at the same time, we can leverage the CosmWasm asset, DeFi assets to the real-world asset. And what we are dreaming is that every platform, whether it's private or enterprise, public, whether permissionless or permission, we would like to connect them through IBC. And personally, I believe that LCP can be a part of that goal, and we can contribute to Cosmos ecosystem.
Great. And Luis, what do you think are the solutions for bridging and interchain communication? Because you talked about many risks now.
Okay, very interesting question. The thing is, if we have a decentralized environment, so attacks, the surface of attack is going to be reduced. So this is the basic idea. For example, let's recap running attack. The attackers got 5 or 9 validators. So they compromised the protocol. At the end, they were able to steal more than $600 million. But for example, let's talk about the Cosmos interchain security. But for me, it's a very cool technology. You can bring the power of all the validators in the Cosmos Hub to any other of the chains. So, for example, if in a chain they had little validators and comes a whale that has a lot of tokens to stake, it may create a transaction that is bad for the community. But what happens if you bring all the power of Cosmos Hub to all the chains in Cosmos? That would be great. So decentralization and to be able to have many validators that could prevent those kind of attacks to happen, that's a very good first measure. Then there is something very particular with these transactions, and it's whenever we rely on an input of a user, we are playing with a protocol. So we have to reduce as much as possible what is the input that the user can enter to the transaction. The input, to reduce what can do with that input. Because if there is no input or there is reduced input, for example, it's complicated in other bridges, technologies, for example, to create fake deposit, to create false events. It's not possible. There is something very particular that applies very well to Web3 and also to other technologies that for sure you already know. I'm talking about social engineering. So the technology could be the best one in the world. But if the developers, for example, click a link that is malicious, the computer is compromised, the keys are stolen. So here it's an advice that applies for all technologies and especially now in Web3. Awareness of the team, the developer team. So as far as they are educated in security, that is very important. So it's going to allow that this kind of attack doesn't happen anymore, or if they happen, they can be reduced impact. So that would be the idea behind the education of security for all the teams. Great.
Karel, how are CosmWasm contracts on SDK compared to CosmWasms on substrate? What's the difference? What are similarities?
So what we're trying to achieve is that it's actually a one-to-one parity. Currently that's not fully possible because technically I think the Golang implementation is currently encoding some stuff in a different encoding with sub-messages. And we don't do that yet. So right now if you were to take the compiled Mars protocol, you can't yet run them on our VM. We had to fork them to change some slight features. those are major issues overall. What's really different mainly is that substrate chains are usually app chains too. So you have a lot more custom messages that you can access. So I do think that opens up more features for smart contract developers that want to go into the parachain ecosystem, especially since a lot of the parachains there do a lot of XCM too. So while with mainly CosmWasm contracts, you might be doing IBC, IBC, IBC hops, what's opening up in the Polkadot is the ability to go through CosmWasm to XCM and then actually call into parachains that don't have CosmWasm at all, that aren't even IBC connected, but that are still trustlessly connected over XCM. And that way you get access to Akala, HydraDX, basically the entire Polkadot network and Kusama network. I think that's a pretty cool feature. We're trying to achieve this too with Near. So having an IBC bridge to Near itself, and then being able to go through shards without actually needing to use IBC. So we'll definitely see a lot more tooling for CosmWasm contracts to actually support these new types of message passings. But to be honest, CosmWasm is designed pretty well. So we don't need to add too much stuff. It's mainly more custom message types.
Well, I was going to ask you about custom message types and how you add them. So you have yeah, all the app protocols, you have a DEX on there, you can add a custom message for the DEX, but you have custom messages also for XCM.
Yeah, so basically for our chain, we generate one giant enum, which is every single transaction type that we can then obviously encode and decode to JSON. So for us, it's very easy to actually support literally every operation that our chain supports without needing to do a lot of code gen or incrementally supporting new palettes. For us, the XCM palette itself is also one of those transaction types. So we basically get XCM support in CosmWasm for free by simply adding that custom message type for our entire chain.
Nice, nice. We have a thing called Stargate queries, or Stargate messages does that, but better typed. Enums are better than any.
Yeah, that's one advantage of doing substrates. Like there's easier integration between CosmWasm and substrate parachains because you remain in the Rust space. So you get all the expressivity of the Rust type system. So far it's been a good experience.
Do you see any risks in CosmWasm expanding to other ecosystem, or is only benefit? Is there?
I think there's only benefit, to be honest. I'm a big believer in WebAssembly as a low-level target for smart contracts. Obviously, you can use the CosmWasm SDK to write your contracts, but technically, all that we do is expose low-level host functions, so people could even write entirely different SDKs on top. What I'm bearish about is actually the expansion of Solidity and the EVM across chains. That's something I dislike seeing because I think it's much more difficult to actually verify Solidity programs for correctness. While with Rust, you have way more tooling, static analysis. So for me, I find it really important to push third-party developers to doing the most secure thing. And to get them to do that, the easiest thing needs to be the most secure. The default needs to be the most secure.
Awesome.
Well said. So I'm going to add one more thing about these contract calls. So I think right now a lot of the design of like IBC has been the actor as a user or as a governance vote or something like that. And so you have, oh, I as a user want to move my tokens from here to here, right? I as a user want to stake my tokens over, I as an XGov module, as a governance vote want to stake my tokens over here, right? And I think what really is going to expand with these custom messages, especially when CosmWasm communicate not just other Cosmos chains, but then with with Polkadot chains. It's interesting is you actually say, okay, we're going to actually compose with different protocols, right? So I'm going to connect my custom thing. I'm going to connect, let's say, Akala over XCM over IBC to my other DEX over here, and somehow have them balance liquidity between them if they happen to have the same pairs. So I think there's a lot of interesting stuff that happens in this space. And I think that DAOs actually are one of the key points to make this secure. Because at the end of the day, all these protocols are owned by something. And all of these hops, so when you're building these custom protocols, who's actually holding these relays? Who's holding these things? And I think the security of DAOs and security of better governance technology is actually essential to build out these large ecosystems. Now when you have a protocol over 3 different chains, like you're trusting obviously the 3 chains themselves, but you shouldn't have any more trust vectors. So can you actually use a chain, the governance as a DAO basically? Can you have your other multi-chain DAOs? I think this whole idea of like, as we are extending the capacity of DeFi and the reach of it and the surface area, we think the governance of these protocols too. So these are very, very other surface area. A lot of people, if you have a multi-sig of 3 core devs as your thing, that's the closest attack vector is social engineering. If you can hack the devs of 3 core devs and they actually have admin right to modify some configuration in your protocol, then you hacked all the chains that are connected through this. So I think actually the governance of those protocols is going to be very important.
And talking about what scared you a little bit, Karel, the expansion of Solidity, maybe we wanted to discuss a little bit about CosmWasm to EVM communication.
Yeah, so a difficulty there, for example, is that Solidity isn't really as expressive in the type system itself. And CosmWasm messages are a Rust enum. So it's already going to be a bit of a pain to actually do that communication. Low level enough, you could definitely do so, and the EVM bytecode itself will fully support this. But Solidity itself isn't really designed to handle messages in this way. So just the way you structure your code, the tutorials itself, it will be a bit more unfamiliar for Solidity developers. Actually, it's a fun thing, Hussein, one of our lead devs, wrote a DAL to EVM bytecode compiler just so that you could get enum support in EVM code. But I do think at some point that we might actually see Solidity gain less market traction. I'm really bullish on FA, which is a basically Rust-inspired language that compiles down to EVM bytecode, which I think could really nicely integrate with CosmWasm smart contracts. And that is basically this perfect marriage between the EVM and all these other chains.
And Susumu, I wanted to ask part of a question from the crowd. How is the community, the CosmWasm community in Japan?
I'm sorry. Actually, I'm very newbie to CosmoWasm comparing to other folks in here. And well, I'd like to encourage and promote people in Japan, but currently it's not that much.
All right. Hopefully see expanding. I don't know if anybody wants to add anything else. Any alpha you want to share with the audience?
If you like DAOs, if you like IBC, WinDAO just launched. It's a project of mine. Check it, wynddao.com. We launched today. It's an interchain DAO based on Juno, based on DAO technology. It's going to rock.
Amazing. Well, thank you guys.